So tonight we're going to talk about human-machine teaming, in particular how humans and robots can work together to accomplish certain tasks that are either very hazardous or sometimes impossible for humans to do by themselves. I'm going to talk for a few minutes, and then we're going to have some demonstrations on the floor, on the stage. We normally do this in outdoor space, so we'll see how it goes on here. So here are some scenarios where, and just a few scenarios where it is extremely dangerous for humans to go in. So for example, train wrecks, inside a tunnel, fire, smoke, all kinds of hazardous conditions. Large blocks of ice, falling off of glaciers. You can send drones, but you don't want to send humans in there. Tall buildings collapsing, another example of where it can be extremely dangerous. And sometimes firefighters and rescue workers risk their lives to save others, but it can also be very dangerous for them. And then airline and aircraft fire. So we're going to talk a little bit about how this is going to be done. So these robots can be completely autonomous, or they can be human navigated. We're going to show you how you can navigate these robots using gesture-based controls. And they don't have to be in proximity of each other. As long as they're connected via the same network, they can be on different parts of the universe or the world. So there are essentially two groups of equipment that are mounted on these robots. You need sensors to really sense the environment. And here we have radars, lidars, thermal cameras, and real sense cameras, which are really standard red, green, and blue cameras. And then we have a bunch of very slow capacity, low power, lightweight, very small form factor devices where all the computing is actually going on board the robots themselves. For example, Jetson Nanos, Raspberry Pis, and Intel NUC. So this is the AI on the edge, and we are pushing it to the extreme edge where we can even more miniaturize some of these devices. So we're going to demonstrate how these robots can actually go and figure out what's going on in the environment, where the human operators can sit at a safe distance and remotely get an input and converse with the robots. So we're going to show you how the robots can work and also give an update on exactly what they're observing and have a conversation with the robots. Now it's going to be completely off the script, so the robots can go crazy and start blabbering or saying things that are completely irrelevant, but we'll see how it goes. Okay. So with that, we're going to get started. So a couple of my students are going to take over and get the robots on the stage. And
pause.
Hi, good evening everyone. So these are our fleet of quadruped robots. I guess you would have seen this earlier, but these are very unique, and we have built a lot of technologies in-house under the supervision of Dr. Aryya, and we have been doing research and development on a day-to-day basis. So I guess there is less enthusiasm in the group, so why don't I let my associate to welcome the robots, Harsh?
Squad, say hello.
Okay, so these tiny headsets onto our head is the augmented reality and virtual reality headsets. So these robots are usually controlled through tablets, but what we have done is we have developed an interface with which we can control these robots using our hand gestures with these augmented reality headsets. And there have been a lot of research and development activities which have been going on in our CARDS center, but with a very few time limited to this particular podium, we'll demonstrate a very few technologies that can be used in a the search and rescue operations or a disaster management situations. So you could see there are two screens which are projected here. One is the orangish screen, that is a feed of a thermal camera which is situated on top of this robot, and the other one is a regular camera which is situated on top of the red robot there. So let's see if we send one of these robots to a disaster management or a search and rescue operations, how does it behave? So we necessarily cannot create a disaster here, though we have created a lot in outside environments. So we have created smoke screens and smoke and dusty environments, but let's project a screen which will have a railway disaster inside a tunnel and then we'll send a robot there to see how it behaves. We can actually have a question here, like these cameras are already on top of the robots. Why do we have to actually send a robot and then talk to it? Let's say there are n number of these robots, for example, 10 to 20. So you can, an operator in charge cannot be looking at all the screen at once, so, but he can talk to them. So let's say I'll ask my associate to take the red robot towards the screen to see how it responds to a disaster. So this one here is a train accident inside a tunnel where the difficulty is increased to the maximum, and we'll take the red robot to this place to see how it interacts with the command. Harsh?
Switch to red.
And the lights on these robots are just as a navigation cue. Let's say if it is yellow, the robot is in navigation mode. Let's say if it is in red, then it has seen something disastrous, or it is trying to communicate with the command in person. So over to Dr. Gangopadhyay.
Describe the scene.
Train wreck in tunnel.
Do you see any humans?
No, I do not see any humans.
Is it safe to go inside?
Not safe. Train wreckage, debris everywhere.
Should we send a rescue team?
Yes, we should send a rescue.
Awesome, thank you, Professor. So this is basically, the robot is actually seeing this environment and we can literally interact with it. Okay, enough of the projection. Let's see one live. So I would ask one of my research associates to just walk into that bunker, which is actually a hunting blind. So we'll consider
Switch
that
to
as a
red.
bunker here. Now we'll see difference in the streams. Let's say this camera has that robot has a standard camera, and it will not be able to see the person, but now since there is light, it is able to actually. So can we make that area a little dark, please?
Do you see anybody inside the bunker?
Yes, there is a person inside the bunker.
Could you please repeat the question?
Okay. Do you see anybody inside the bunker?
The image is dark and blurry.
Awesome. So let's switch screen.
No, there is no one inside the bunker.
Switch streams.
Switching stream now.
Harsh? Okay, I'll take the black one to.
So switching streams essentially means that it's going to change the modality from a regular
Switch to
camera
black.
to a thermal camera.
So that is a standard camera which was not able to actually see that there is a person inside the blind. Let's say we take the robot with a thermal camera which is actually able to recognize that there is a person inside.
Do you see anybody inside the bunker?
Yes, I see a person inside the bunker.
What is he doing?
Person standing near a camera.
That was off script. I did not know what he was going to say.
So that is quite a normal response from VQA, which is installed on top of the robot, and everything is happening on top of the robot. There is no cloud server here, there is no edge, so these are all edge devices. So along with this, we have also developed other capabilities which will be used for disaster navigation scenarios. For example, let's say there is a debris and then it has to crouch inside an environment. Harsh, can you?
Black crouch.
So it can go to the lowest of its height. Let's say there is an object which it has to actually tiptoe and then see.
Black
so it can
tiptoe.
also do that. So this is the maximum height which the robot can actually go. And there are a lot of other developments which we are unable to demonstrate due to time constraint. But yeah, this marks the end of our demo right here under the supervision of Dr. Aryya. There are other developments which is going on here. And thank you all.
So I would like to get all the developers to please come to the stage.
Squad, say thank you.
Thank you.